Dear students, sometimes we say sum is very tough, although not even a single tough, not even a single sum is tough in the world. We say tough because either we are out of practice or we are forgetting some previous important facts of the chapters in mathematics. And certain sums baffle our mind. We can solve, we can do each and every type of sum that we say difficult easily if we have systematical practice. Without practice, without systematical practice, we are not able to solve all kinds of sums easily. And systematical practice means we have to think about the sum, we have to know the nature of the sum, and then we have to start, or we start to solve the sum. It is not a matter of you only, it is a matter of all. Today, I have taken one sum from differentiation, from differential calculus, and see what type of sum it is. You can understand easily. Sum is given to you here. A function f such that r tends to r satisfies the equation fx plus y is equal to fx fy for all x, y in R, and fx cannot be 0. For any x in R, let the function be differentiable at x is equal to 0 and f dash 0 is equal to 2. So that f dash x is equal to 2fx for all x in R. Hence, determine fx. And for the solution, we start from here. Fx plus y is equal to fx into fy for all x, y belongs to R. It is given. This condition is given. Therefore, f0 is equal to f0 into f0.
Yes, I'm stopping. Go.
Or f0 into f0 minus 1 is equal to 0. From this, either f0 is equal to 0 or f0 minus 1 is equal to 0. But f0 cannot be 0, it is given in the sum. Therefore, f0 is equal to 1. This is equation first. Now, f dash 0 is equal to, it is also given. From this, we can use limit s tends to 0, f0 plus s minus f0 by h. Limit s tends to 0, fs minus 1 by h is equal to 2 because f0 is equal to 1, it is given from equation 1. Not given, but from equation 1 it is. And f dash x is equal to limit s tends to 0, fx plus s minus fx by h is equal to limit s tends to 0, fx into fx minus fx by h. We know from the sum, from the given condition of the sum, fx plus y is equal to fx into fy. In the same way, this term has been written. Is equal to fx, limit, taking fx common, limit s tends to 0, fx minus 1 by h. Value of this we have found out before, 2. Therefore, this term can be written as fx into 2. And therefore, f dash x is equal to 2fx. This is the first part of the sum that is proved here. Now for the determination of fx, and this is the second part. F dash x by fx is equal to 2. Now integrating both sides between 0 to x, we have upper limit x, lower limit 0, f dash x by fx is equal to 2x. How? On integration, here will be 2 dx, and we know integration of dx is x, so here will be 2x. This is right side. And in left side, we have to put fx is equal to t. Then f dash x dx will be f dash x dx will be dt. Then here will be dt by t, that is log t. Now first stop this limit and write 1 by t dt, integration of 1 by t dt, that is log t. Now put the value of t as fx, because I told you for fx put t. So for t, write here fx, and now use limit, upper limit x lower limit 0 is equal to 2x. Then we know that from this log e f x minus log e f0 is equal to 2x, or log e fx is equal to 2x. Here f0 is equal to 1. I have proved, found out the value, f0 is equal to 1. And we know log 1 is equal to 0. So this part will be 0. Then the remaining part will be this, log e fx. So I have written here log e fx is equal to 2x. And from here, fx can be written as e power 2x.